This video discusses calculations for isotonicity and the theory behind those methods. So let's start with this question. According to the hemolytic method of measuring tonicity, a solution that liberates hemoglobin is. So the answer to this one is B, hypotonic. So when we talk about isotonic solutions, we are usually referring to parenteral and ophthalmic dosage forms. Bakit? Because our red blood cells will be affected kapag hindi isotonic yung fluid that would be administered. So usually you can see isotonic saline sa mga pharmacy and they are at 0.9%, meaning that for every 100 ml of fluid, there is 0.9 grams of sodium chloride. So with that is an isotonic solution. However, if this amount was higher, then it would be a hypertonic solution, meaning mas mataas yung osmotic pressure niya kaysa sa dugo natin. And remember, where sodium goes, water follows, meaning the fluid in the RBCs will prefer to go out here now, resulting in crenation or parang nag-shrivel up yung red blood cells natin. So here now you can see there's plasmolysis or crenation. Kapag naman the solution is hypotonic, meaning mas malabnaw yung fluid that has been administered compared sa dugo natin, pasok yung tubig sa red blood cells kasi again, where sodium goes, water follows. So here, water would prefer to be inside your red blood cells. So this will result in hemolysis or swelling. So going back to the question, alin daw yung solution that liberates hemoglobin? When we say liberating hemoglobin, may hemolysis kasi lalabas yung hemoglobin from our red blood cells. So the answer is B, hypotonic. Question. Class 1 method of adjusting tonicity includes. So the answer to this one is 1 and 3. So there are different methods for adjusting tonicity. My class 1 at my class 2. So si class 1, this will refer to turning a hypotonic solution into an isotonic solution, meaning we will add solute. So an analogy would be malabnaw na juice nilagyan natin ng powder. Class 2 naman, this will refer to turning a hypertonic solution into an isotonic solution. So to do that, we will have to add solvent. So again, the analogy, a saturated solution of your juice, we will add water para maging isotonic. So your class 1 and class 2 has two different methods. So we'll discuss each of them one by one and tackle different problems for each. So let's start with class 1, your D method. So your D method is your freezing point depression method or also known as cryoscopic method. Kasi yung basis for adjusting the tonicity ay yung freezing point sa dugo at luha natin, which is negative 0.52 degrees Celsius. So for this, we will add solutes to match the freezing point of body fluids. Therefore, magmatch na din yung tonicity. So diba recall that an isotonic solution again is 0.9%. So therefore, it follows na yung 0.9% isotonic saline, yung freezing point niya is negative 0.52 degrees Celsius. So therefore, this will be a constant in our calculations for the D method. Okay, so let's tackle a problem so you can see what I mean. So for this problem, it asks how much sodium chloride is required to render 100 ml of 1% solution of penicillin G potassium isotonic with blood serum. So given is 1% of pen G potassium, its freezing point would be negative 0.11 degrees Celsius. So step 1 is that we will apply the ratio and proportion of the freezing point of blood with the drug solution. 0.9% over negative 0.52 degrees Celsius. So diba remember, 0.9% is the concentration of isotonic saline. And therefore, since isotonic siya, its freezing point would be negative 0.50 degrees Celsius. Tapos, ang tinatanong dito is how much sodium chloride is required. So, how much daw yung kailangan para maging isotonic si PenG potassium. Tapos, we will put X here kasi hindi pa natin alam. And the freezing point para maging proportionate, 0.11 degrees Celsius. So remember, the percent here is sodium chloride. Hindi 1% of your PenG kasi yung hinahanap is how much sodium chloride is required. So dapat proportionate, diba? So for this, the answer is 0.19%. Now we will do step B. So subtract the ideal amount of sodium chloride with the answer in A. So remember, the ideal amount of sodium chloride is 0.9% degrees Celsius kasi this is isotonic. So 0.9% minus 0.19% is equal to 0.71%. So yung tinatanong dito is the amount of sodium chloride in grams. So remember your basics, 0.71% is equal to 71 grams per 100 ml, diba? So therefore, grams yung hinahanap, the answer is 71 grams. So we will need 71 grams of sodium chloride to render 100 ml of 1% solution of PenG potassium isotonic. Okay, so next question. How much sodium chloride is required to turn 50 ml of a 1% solution of epinephrine hydrochloride isotonic with body fluids? The freezing point of 1% epi is a negative 0.17 degrees Celsius. So again, we will apply the ratio and proportion. So 0.9% over negative 0.52 degrees Celsius equal to unknown percent of sodium chloride. Tapos, the freezing point of your epinephrine hydrochloride, which is negative 0.17 degrees Celsius. So again, ratio and proportion natin, which is 0.29%. Tapos, step 2, we subtract the ideal amount of sodium chloride with the answer in the first step. So, diba, the ideal amount would be 0.9% minus 0.29% equals to 0.61%. Now, if you look at the question, 50 ml yung volume. 0.61% is equals to 61 grams over 100 ml. So again, we will do ratio and proportion para malalaman natin how much sodium chloride is needed para maging isotonic yung 50 ml of this solution. So 50 ml, ratio and proportion natin. So the answer would be 30.5 grams of sodium chloride. So that is the answer, 30.5 grams of sodium chloride. So now let's proceed to your E method. So this is still a class 1 method. So your E method is also known as your sodium chloride equivalency method kasi it uses an E value or a sodium chloride equivalent value. So your E value is the gram of sodium chloride present for every gram of drug that has theoretically the same osmotic effect. So for example, the E value of your epinephrine is 0.25. So that means 0.25 grams of your sodium chloride will have the same osmotic effect of 1 gram of epinephrine. So what happens if the E value is not given? Then, syempre, we will have to compute. So there are two methods in determining your E value. So we have your old method and new method. So the old method of computing for your E value is 17 times L-iso over molecular weight of the drug, where L-iso is the Van Hoff factor of the drug times 1.86. And the new method of determining your E value would be the molecular weight of sodium chloride over the Van Hoff factor of your sodium chloride times the Van Hoff factor of the drug over the molecular weight of the drug. So let's discuss first what is I, or your Van Hoff number or Van Hoff factor. So I is the number of ions that form when the compound dissociates. So there are three categories to this: my strong electrolytes, weak electrolytes, and non-electrolytes. So for your strong electrolytes, once they dissociate completely, so 100%. For example of this one would be your hydrochloric acid. So when it dissociates, it will dissociate fully into hydrogen and chloride. That's why its Van Hoff number or Van Hoff factor is 2. So other examples of your strong electrolytes would be your strong bases and your strong acids. So review kayo sa chemistry nyo. Your weak electrolytes naman, it will only dissociate at around 80%. Meaning, for example, sodium chloride is a weak electrolyte. So when sodium chloride dissociates, only 80% will become sodium and chloride, whereas the remaining 20% will still remain as sodium chloride na buo. That's why its I, or your Van Hoff number, will be 1.8 lang. Now, what about your non-electrolytes? So your non-electrolytes will not dissociate when in solution. For example, would be your glucose, sucrose, lactose. So once they will be in a solvent, they will not dissociate. Kaya, it will still remain as 1 kasi it is a non-electrolyte. So from that discussion, we can conclude that the Van Hoff number of your sodium chloride is 1.8. So it is important to remember the molecular weight of your sodium chloride, which is 58.5 grams per mole, and the Van Hoff number of your sodium chloride, which is 1.8. So let's try to solve a problem so that we can apply what we've just discussed. So now let's solve this practice problem. So how many grams of sodium chloride should be used in compounding the following? So given dito is the Van Hoff factor of ingredient Z, which is 1.8, and its molecular weight, which is 212 grams per mole. So the E value is not given, so therefore we will first have to solve for that. So let's practice with the old and the new method. So the E value of your ingredient Z would be 17 times Li of the drug over its molecular weight. So remember, the Li's of the drug is the Van Hoff number of the drug times 1.86 over the molecular weight, which is 212 grams. If we compute this, we will get 0.27. So let's practice using the new method. So E value of the drug would be equal to the molecular weight of sodium chloride, which is 58.5, over the Van Hoff number of your sodium chloride, which is 1.8, times the Van Hoff number of ingredient Z, which is 1.8, over the molecular weight of the drug, which is 212. So if we calculate all of that, we are going to get 0.275 or 0.28. So halos magkapareha lang yung E value. So now that we have our E value, we can now solve the problem as to how many grams of sodium chloride should be used in compounding the following. So for this one, we will first have to determine the amount of sodium chloride that should ideally be present. So remember, kapag isotonic yung hinahanap and sodium chloride, so the ideal percentage would be 0.9%. Tapos grams yung hinahanap, so remember 0.9 grams in 100 ml solution. But if you look at the problem, the volume is 60 ml. So we will have to multiply this by 60 ml. So the answer to this would be 0.54 grams. So the ideal amount of sodium chloride that should ideally be present is 0.54 grams. Next step is to determine the amount of sodium chloride present contributed by the amount of drug. So to get this value, we will multiply the E value of ingredient Z, which was 0.28, times the gram of drug present in the solution, which is 0.3 grams. So saan galing si 0.3 grams? So if you look at the prescription here, ingredient Z is present in the solution as 0.5%. Now, if you remember your basics, kapag 0.5% yung concentration, it means that for every 100 ml of the solution, there is 0.5 grams present of the drug. Pero the volume here is 60 ml. So we will have to adjust it for 60 ml, which is 0.3 grams. Kaya it's 0.28 times 0.3 grams. So if we multiply 0.3 times 0.28, we will get 0.084 grams. So the next step would be to determine the amount of sodium chloride that needs to be added. So for this is very simple. We will have to subtract answer we got from A, which is 0.54 grams, minus the answer that we got from B, which is 0.084 grams. So if we compute this, the answer would be 0.456 grams. So this is now the final answer. So how many grams of sodium chloride should be used in compounding the following? It would be 0.456 grams. Okay, so now let's tackle this type of problem. So paano naman kapag given yung mga E-values pero there are multiple drugs present? So let's first tackle the first step. So similar lang sa previous problems natin that we will have to first determine the amount of sodium chloride that should ideally be present. Recall, kapag isotonic solution tapos sodium chloride, 0.9%, which is equal to 100 ml of fluid over 0.9 grams of sodium chloride. Pero if you look at the volume here, it is 20 ml. So we are going to have to adjust this for 20 ml. So the answer to this is 0.18 grams. But if you look at the question, milligrams yung tinatanong for sodium chloride. So we are going to have to convert grams to milligrams. So recall your basics, 0.18 grams would be 180 milligrams. So that is the ideal amount of sodium chloride that should ideally be present kapag milligrams yung unit. Now let's go to step B. So as you can see, there are different drugs present. So how are we going to do this? So we are just going to calculate the milligrams of sodium chloride present using the E value and the milligram of drug. Tapos we will add all of our results. So for example, let's do brimonidine tartrate. So the E value of brimonidine is 0.13 times the milligram of the drug, which is 40 milligrams. So the answer to this would be 5.2 milligrams. Now let's go to timolol. So for timolol, its E value is 0.14. Multiply natin by 75 milligrams. The answer would be 10.5 milligrams. And then lastly, for chlorobutanol, the E value is 0.24 times 55 milligrams. Answer would be 13.2 milligrams. So now that we have these values, we are now going to add them all. So 13.2 plus 10.5 plus 5.2 would be 28.9. So that is the milligrams of sodium chloride present. So for step C, similar procedure lang. So the answer from step A minus natin sa answer sa step B. So 180 minus 2, 28.9 rather. So the answer to that would be 151.1 milligrams. So that is now our final answer. So how much milligrams of sodium chloride should be used in compounding the prescription? It would be 151.1 milligrams sodium chloride. Okay, so tapos na tayo sa class 1 methods of adjusting tonicity. So na-discuss na natin yung D method and na-discuss na din natin yung E method. So now let's proceed to your class 2 method. So your class 2 methods, to reiterate, is turning a hypertonic solution into an isotonic solution. So an analogy, a very saturated solution of juice, linagyan natin ng tubig. So for this, we will have to add solvents. So your class 2 methods again have two types, your White-Vincent method, and your Sprouse method.
So in the White-Vincent method, there will be the addition of water, followed by the addition of isotonic or isotonic buffered solution to reach the final volume of the preparation, meaning may dalawang answers to the problem, the volume of water and the volume of the buffer solution. There's also the Sprouse method. So the Sprouse method is a variation of the White-Vincent method, wherein fixed yung weight sa drug to 0.3 grams because 0.3 grams is 1% of 1 fluid ounce solution. If you recall, 1 fluid ounce is 29.57 ml or around 30 ml. Kaya naging 0.3 grams. So for your Sprouse method, it uses what we call a V-value. So the V-value is 0.3 grams times E-value times 111.1. So when we say V-value, this is the volume of water for every 0.3 grams of the drug. So meaning kapag may V-value yung drug of 3, meaning every 0.3 grams of drug will need 3 ml of water para maging isotonic. So again, similar sa White-Vincent method, it will also have the volume of water and the volume of buffer solution. In this instance lang, we will use the V-value to calculate the volume of water. So let's try to apply these two methods in the succeeding problems. So here, available in the pharmacy is an isotonic boric solution. So how many ml of purified water and how many ml of isotonic boric acid vehicle should be used in compounding this prescription. So let's try to solve this using the White-Vincent method. So first, we will have to look for the volume of water using the formula. So this will need the weight of the drug, which is 0.1 grams, times the E value, 0.15 times 111.1. This is equal to 1.665 or around 1.7. Now let's calculate the volume of the buffer solution, which is the total volume of solution, which is 200 ml, minus the volume of water, which is 1.7. So the answer to this is 198.3 ml. So those are our answers, 1.7 ml of water and 198.3 ml of buffer solution. So let's try to solve this using the Sprouse method. So your Sprouse method, again, uses the V-value. So let's use the formula. V-value is equals to 0.3 grams times the E-value of the drug, which is 0.15, times 111.1. So this is equal to 4.995, or let's round that up to 5. So in this instance, the V-value of zinc sulfate is 5. So what do we do with this information? We can use this information to calculate the volume of water. So for the volume of water, we will need the weight of the drug, which is 0.1 grams, times the V-value. So remember that the V-value in this instance is 5, meaning that for every 0.3 grams of the drug, this will require 5 ml of water. So if we calculate this, we will get 1.7 ml. So the volume of water needed is 1.7 ml. And then now we can calculate the buffer solution. So to do this again, we subtract the 1.7 ml from total volume of the solution, which is 200 ml. So the answer is 198.3. So if you compare our answers, magkapareha lang if we use either White-Vincent or Sprouse. Sige, paano naman kapag dalawa yung given na drug? So here, we have ephedrine sulfate and chlorobutanol. Tapos they have their own respective E values. So how many ml of distilled water and buffered solution should be used in compounding the prescription? So same steps lang sa kanina, only this time we will add the two volumes computed. So let's try to solve. So here you can see that ephedrine sulfate is 1% of the solution. So remember, 1% is equal to, for every 100 ml of the solution, there is 1 gram of the drug. Now, if you look at the final volume, 50 ml siya. So, kailangan natin i-adjust. So, this will be 0.5 grams of ephedrine sulfate. Tapos, si chlorobutanol naman, let's solve. So, si chlorobutanol is 0.4%. So, for every 100 ml, may 4.4 rather grams of the drug. Adjust for 50 ml, it's 0.2 grams. So this is now the weight of the drug that we will use in our formula. So let's add in the e-value. So 0.5 grams times 0.23 times 111.1, tapos 0.2 grams times 0.30, the e-value of your chlorobutanol, times 111.1. So the answer to this is 12.83. So run up natin to 12.8. Tapos, 0.2 grams times 0.3 times 111.1 is 6.7. So these are the respective volumes of water needed. So what we're going to do is we're going to add the two volumes. So 12.8 plus 6.7 is 19.5 ml. So this is now the volume of water needed. So for the volume of the buffer solution, simple na lang, we will subtract 19.5 ml from 50 ml. So the answer to this is 30.5. So 30.5 ml is now the volume of the buffer solution. So these are our answers. 19.5 ml of water and 30.5 ml of buffer solution. How about we compute this using Sproul's method? So for the Sproul's method, we're going to have to look for the V values first. So again, 0.3 grams times 0.23, kasi that's the E value of your ephedrine, times 111.1. So this is ephedrine, tapos chlor. So for chlorobutanol again, 0.3 grams times 0.3 times 111.1. So the answer to this is 7.66. So let's round that up to 7.7. Tapos the answer for this one is 9.99. So let's round this up to 10. Okay, so these are the V values. So using the V values, we can now look for the volume of water. So to look for the volume of water needed, we will have to multiply the weight of the drug, which is 0.5 grams in the case of ephedrine, times the V value. So remember, for your V value, every 0.3 grams of the drug requires 7.7 ml of water. So if we solve this, we will get 12.83 ml. And then for chlorobutanol, we multiply 0.2 grams times its V value, which is 10. So every 0.3 grams of the drug requires 10 ml. This will result to 6.7 ml. Now, if we add these two volumes together, we are going to get 19.5. And now to solve for the buffer solution, we will have to subtract 19.5 ml from the final volume, which is 50 ml. So this will result to 30.5 ml. So these are now our final answers. The volume of water is 19.5. Volume of your buffered solution is 30.5 ml. So same answers lang sa White-Vincent method. Now let's tackle a few theoretical questions. So the E value of ephedrine sulfate is 0.23. This means so the answer is C. So this means that 1 gram of ephedrine sulfate is equivalent to 0.23 grams of sodium chloride. So remember, the E value is the amount of sodium chloride that is theoretically equivalent to 1 gram of a drug or has at least the same osmotic effect. So again, if E value is 0.23, it is sodium chloride yung 0.23, hindi yung drug. And then last, the basis of the v-values by Sproul's method is so the answer to this one is A. 0.3 grams of the drug in 1 fluid ounce of the solution. So again, 1% of your fluid ounce is roughly zero point 0.3 grams kasi 1 fluid ounce is around 29.57 ml. So round that up to 30 ml. So 1% of that is zero point 0.3 grams. So that is the fixed weight when we want to compute for v-values using the Sproul's method.